Andrew Krichkevich here of the International Research Institute for Climate and Society, IRI, at Columbia University. Now we're going to dig deeper into the African Flood and Drought Monitor provided by Princeton University. And we're going to create a time series of daily rainfall for a specific point. And this is something that Concern Worldwide was doing for various points of interest in Somalia to get an idea of, at a specific point, an important point from Concern's perspective, what was the rainfall like for a previous season of interest. So in this case, the question was, for the rainy season, for the Dare rains from roughly September, October, November through December, what were the rains like for specific points? And eventually this would help Concern answer the question, which areas in Somalia actually experienced worse rains relative to other areas. Now this isn't the only variable that factored into this idea of which areas are more at risk of drought, but this was the rainfall component. Which areas actually saw rainfall, less or more rainfall relative to other areas of interest in Somalia. So we're back here at the main welcome page of the African Flood and Drought Monitor. Like last time, the default is this drought index. We could go up here to the top where it says meteorology and click on precipitation, satellite precipitation. Now we have a visual of rainfall on the daily time step. So again, this is the December 26th rainfall estimates. This is not ground truth. This is not perfect. This is an estimate. Let's go ahead here and zoom in on Somalia. And let's see, right about there. And now, just like we did in the previous video, when we were trying to get an idea of the geographical distribution of rainfall over a period of interest, we're going to change this initial date to September 26th, and then keep the end date constant here. Click Update. We got to click Pause, otherwise it'll cycle through. And then what we're going to do is go up to the top here. Instead of animation, we're going to click on Point Data. So when we click on Point Data, we see a new map. And what we're going to do here, where it says Point Data Selection, we're going to click on the meteorology button. And then we're going to go, we have to go back to the dates, and we're going to select, let's start at, let's say 9/3, so that's September 3rd. And we're going to put the end point, let's say at 12/26, click Update. Then we're going to click on our area of interest. So the last analyses we were focused on the Baidoa area. Let's click on that area. And then as we click, automatically generated is a chart which shows different variables, different meteorological variables. At daily average wind speed, daily minimum temperature, daily maximum temperature, and precipitation. So we're only interested in precipitation, so we could click off the other variables, and as we do, they disappear. And now we just have precipitation. And then we see from September 17th all the way through December 2017, these blue bars are indicating how much rainfall fell on certain days. So where we see no blue bars, that means we did not get rainfall on a given day. So right here, I'm mousing over the map approximately in early September. So we see Tuesday, September 12th, 2017, precipitation in millimeters a day, 0. And that's consistent for all these other days until we reach September 21st, 2017. We see precipitation was 6.48 millimeters. So that's an interesting data point when we're trying to get an idea of how rainfall performed in Baidoa area. We could also see some other aspects of rainfall. We could see that we had a large gap from September 21st to October 12th. So whereas we actually saw some rainfall on September 21st, if we're trying to get an idea of if that rainfall was enough to really begin the rainy season, that this chart would prompt us to maybe explore the situation further because the satellites did not pick up any rainfall for a number of days afterwards. Another interesting feature here, we see some extremely heavy amounts of rainfall. November 1st, almost 60 millimeters of rainfall, followed by November 4th, 143 millimeters of rainfall. So this is really interesting to see this cluster of a few days of very heavy rainfall in early November. Then we see this gap again from November 11th to November 26th, so about 2 weeks with no rainfall. So when we're trying to identify the temporal variability of rainfall over a given period of interest, these gaps are very interesting to us, and they were too concerned to get an idea of how rainfall performed at a given point over a period of interest. Now, once again, this data is not the only way to perform this analysis. This is one rainfall data set that has found useful, generally speaking, and has deemed it to be fairly accurate for this exercise. But yeah, and if you would like to see the latitude and longitude coordinates of where you clicked, you could check over here. And this is always good to kind of confirm with your area of interest to see if you are somewhat near where you tried to click. So this is saying coordinates 3.206 by 43.660. So it would be good to check this with the known lat long coordinates of your area.